Thursday, August 20th, 2026. Welcome back. And today we need to talk about something that has been building for months and has finally reached a point where it cannot be ignored, dismissed, or explained away as ordinary background noise. Colombia, Indonesia, Japan, Spain, the United States, 5 countries spread across 4 different continents, all making headlines for the same reason within the same stretch of weeks. The ground has been moving violently and repeatedly in places that don't normally share the same news cycle, and people everywhere are asking the exact same question. What is actually happening? Is this just an unusually active year? The kind of statistical clustering that happens now and then on a planet with millions of earthquakes annually? Or is something deeper going on beneath the surface of the Earth that connects all of these separate disasters into one larger pattern? By the end of this video, you are going to understand exactly what has struck each of these 5 regions, the real human cost behind each event, the specific tectonic reason each one happened where it did, what the broader global data is actually telling scientists about 2026 as a whole, and what any of this actually means for the people living through it. Let's start with the earthquake that has generated the most devastating headlines of the entire sequence, the one that struck Colombia on August 10th. At 7:34 in the morning local time, a massive earthquake measured by the United States Geological Survey at magnitude 7, 4, with some assessments placing it as high as 7. 5 struck the department of Chaco in western Colombia. The epicenter was located just 5 kilometers east of the small town of San Jose del Palmar, roughly 150 miles from the capital, Bogota, where the shaking was still strongly felt despite the distance. This was, according to Colombia's own geological service, the most powerful earthquake to strike the country in an entire decade, and Colombian officials would later describe it as the strongest to hit the nation this century. The destruction was immediate and widespread. Buildings collapsed across multiple major cities, including Cali, Pereira, Quibdó, Manizales, Armenia, and Buenaventura. In Pereira, a 7-story building at Plaza Bolívar came down entirely, and rescue crews spent hours digging through the rubble searching for survivors. In a moment that captured just how chaotic those first hours were, passengers riding a cable car system found themselves trapped inside their cabins when the earthquake struck, suspended above the city with no way down, and it took roughly 6 hours before rescue teams were able to safely evacuate everyone still stuck inside, finally reaching solid ground around 1:30 in the afternoon local time. Colombia's aviation authority suspended flights to numerous cities across the affected region, including Quibdó, Armenia, Cartago, Buenaventura, Cali, and Rio Negro near Medellin, while a nearby volcano, Puracé, saw its own activity disrupt air traffic around Popayán at the same time, adding volcanic uncertainty on top of the earthquake crisis, and stretching the country's emergency response capacity across 2 entirely different kinds of natural hazard simultaneously. The death toll climbed steadily and painfully over the following days, moving from an initial count in the dozens up through 111, then 132, and ultimately, according to the most recent confirmed figures, reaching at least 329 people killed, with more than 4,600 others injured and 247 people still listed as missing. Colombia's president, Abelardo de la Espriella, addressed the nation directly as the toll continued climbing, and the government formally declared a national emergency, launching large-scale search and rescue operations across the affected departments and calling on international humanitarian partners to help mobilize medical aid for the injured. Organizations like Direct Relief moved quickly to coordinate emergency medical supplies for hospitals overwhelmed by the sheer number of injured arriving in the earthquake's immediate aftermath. The earthquake was felt not only across the majority of western and central Colombia, but also in neighboring Ecuador and Panama. The coastal regions of both countries share the same underlying tectonic vulnerability, because this entire stretch of coastline sits directly above the convergent boundary where the Malpelo Plate subducts beneath the North Andes Plate, a section of the South American plate system responsible for some of the most significant earthquake hazard anywhere in the Andes region. It's worth noting that this is far from the first time this general area has produced a major, historically significant earthquake. Back in 1906, an earthquake estimated at magnitude 8. 8 struck near Colombia's Pacific coast, remaining to this day the strongest earthquake recorded anywhere near the country since the year 1900. And in the years leading up to this month's disaster, the broader region had already shown signs of persistent activity, including a magnitude 6. 3 earthquake that struck Cundinamarca in 2025, injuring dozens, part of a long ongoing pattern of subduction-driven seismicity along Colombia's Pacific margin that geologists have documented for well over a century. Now, let's turn to Indonesia, a country that has appeared in global earthquake headlines twice within this same general window of time, most recently and most severely on August 15th, when a magnitude 7 earthquake struck off the northern coast of Flores Island. The epicenter sat roughly 68 kilometers north-northwest of the city of Inde, at a shallow depth of approximately 10 kilometers, and that shallow depth is precisely why the destruction was so severe and so immediate. Indonesia's Meteorological and Geophysical Agency, BMKG, issued a tsunami warning within minutes covering 4 separate provinces: West Nusa Tenggara, East Nusa Tenggara, South Sulawesi, and Southeast Sulawesi, and tsunami waves over half a meter high were subsequently recorded reaching the coastlines of Bulukumba and Sape. More than 230 aftershocks rattled the region throughout the day, the strongest reaching magnitude 6. 2, and later that same Saturday, a completely separate magnitude 6. 9 deep focus earthquakes struck thousands of kilometers away in North Sumatra, a reminder of just how much seismic ground this single archipelago nation covers on any given day. As of the most recent reporting, the confirmed death toll from the Flores earthquake stands at 53 people, with hundreds more injured and thousands displaced, and officials have warned the number is likely to continue rising as rescue crews work to reach communities that remained cut off after landslides severed the Trans-Flores Highway, the island's single primary road corridor connecting Labuan Bajo in the west to Larantuka in the east. Now, Jaikia Regency, the area closest to the epicenter, has remained largely inaccessible by land, forcing rescue teams to reach stranded residents by boat instead, while damaged cell towers have cut off phone and data service for thousands of people at the exact moment they most needed to call for help. This is not an unfamiliar disaster for this particular stretch of Indonesian coastline. In December of 1992, an earthquake of almost identical magnitude struck this same region and triggered a tsunami that killed approximately 2,500 people. And the improvements in warning systems and evacuation protocols made since that historic disaster are widely credited with keeping this year's death toll dramatically lower than it otherwise might have been. Indonesia sits directly on the Pacific Ring of Fire at the collision point of the Indo-Australian, Eurasian, and Pacific tectonic plates. And this specific earthquake ruptured along what's known as the Flores back-arc thrust system, a zone where compressional stress forces one section of crust up and over another, precisely the kind of vertical displacement of the seafloor that generates a tsunami. And Flores is only one entry in a long, sobering list. The catastrophic 2004 Sumatra earthquake and tsunami killed roughly 230,000 people across a dozen countries. The 2018 Palu earthquake killed more than 4,400 people through a combination of tsunami and soil liquefaction. And the 2010 Mentawai earthquake generated a tsunami that killed more than 400 people, with almost no warning time at all. Indonesia's National Disaster Management Agency, BNPB, has confirmed that this month's Flores disaster damaged at least 346 houses, along with 87 educational facilities, 18 health facilities, 5 places of worship, and 6 government buildings, a reminder that the destruction from a major earthquake extends far beyond homes into the entire fabric of a community's basic infrastructure. Now, let's move to Japan, a country whose entire modern infrastructure and public safety culture has been built around the reality that major earthquakes are not a question of if, but simply a question of when and where. Earlier this year, on April 20th, a significant magnitude 7, 5 earthquake with a moment magnitude estimated between 7, 4, and 7. 5 struck off the Sanriku coast of Honshu along the Japan Trench at a depth of 35 kilometers. This earthquake, classified as a thrust event, affected the Tohoku region and Hokkaido, generating a tsunami reaching 80 centimeters and damaging 233 structures across the affected coastline. Remarkably, given the magnitude involved, this earthquake resulted in only 10 reported injuries, a testament to just how thoroughly Japan's building codes, tsunami warning systems, and public earthquake preparedness culture have been refined over decades of hard experience with exactly this kind of seismic event. What makes the Sanriku earthquake particularly interesting from a scientific standpoint is what came before it. The event was preceded by a documented sequence of 162 foreshocks, measuring magnitude 4, 0 or greater, including a substantial magnitude 6. 8 foreshock, back on November 9, 2025, more than 5 months before the main rupture finally occurred. In hindsight, seismologists now recognize that extended foreshock sequence as a genuine precursor to the larger event. Though, as is almost always the case in seismology, that recognition only became possible after the larger earthquake had already struck. The earthquake itself lasted roughly 12 seconds, generated a peak ground acceleration of 0, 404 times the force of gravity, and was followed by 17 aftershocks of its own measuring magnitude, 4, 0 or greater, the strongest reaching magnitude 5. 6. Japan sits at one of the most geologically complex junctions on the entire planet, where the Pacific Plate, the Philippine Sea Plate, and the Eurasian Plate all interact simultaneously, and the Japan Trench specifically marks the zone where the Pacific Plate is being forced beneath the overriding plate carrying the Japanese archipelago, a subduction system responsible for some of the largest and most destructive earthquakes ever recorded anywhere on Earth, including the catastrophic 2011 Tohoku earthquake and tsunami that killed nearly 20,000 people and triggered a nuclear disaster at the Fukushima power plant. Now, let's turn to a country that most people would not typically associate with major earthquake risk at all, Spain. Throughout August, the province of Granada in southern Spain has been experiencing an ongoing seismic sequence, with several earthquakes exceeding magnitude 4 striking the region, accompanied by numerous smaller aftershocks continuing in the days since. Spain's National Geographic Institute has maintained continuous monitoring of seismic activity across the Iberian Peninsula and the Canary Islands throughout this sequence, tracking the swarm as it has continued to unfold. While a magnitude 4 earthquake sequence is genuinely modest when placed alongside the magnitude 7 events striking Colombia, Indonesia, and Japan this year, its significance lies less in its raw power and more in what it represents. Evidence that seismic activity has been notably elevated not just along the most obvious, well-known plate boundaries like the Pacific Ring of Fire, but also across regions of the world that experience earthquakes far less frequently and where the population and infrastructure are generally far less prepared for even moderate seismic events. Southern Spain sits along the broader Africa-Eurasia plate boundary zone, a considerably slower and more diffuse tectonic boundary than the fast-moving subduction zones responsible for the Pacific's largest earthquakes, but a genuine and active boundary nonetheless, one capable of producing damaging earthquakes even if they occur far less frequently than in more obviously hazardous regions of the world. Granada, in particular, has a documented history of periodic seismic swarms tied to the ongoing slow-motion convergence between the African and Eurasian plates beneath southern Spain, and while none of this month's tremors have approached anything close to a catastrophic scale, the persistence of the sequence throughout August has been enough to keep national seismologists monitoring the region closely for any sign of escalation. And finally, let's turn to the United States, where a very different but equally significant pattern has been unfolding across Northern California throughout this year. Rather than a single dramatic earthquake making headlines, California has experienced an extended sequence of moderate but historically unusual earthquakes concentrated along the Maacama and Bartlett Springs faults, two major branches of the broader San Andreas fault system running through the Coast Ranges north of San Francisco. In June, a magnitude 5.6 earthquake struck near Ukiah and Willits in Mendocino County, and according to seismologists tracking the region, this was the largest earthquake ever recorded on the Maacama Fault across the entire span of modern seismic monitoring. In the weeks that followed, the neighboring Bartlett Springs Fault, which had produced essentially no earthquakes of magnitude, 4 or greater for 22 consecutive years, suddenly produced multiple events at that magnitude within a single month, including earthquakes near Cloverdale and Cavello. Separately, a peer-reviewed study published this year in the Journal of Geophysical Research, Solid Earth, led by researchers from the University of Bern, working alongside colleagues from Northern Arizona University, the United States Geological Survey, and the University of California, San Diego, used a physics-based model reconstructing a full 1,000 years of earthquake history along the southern San Andreas and San Jacinto faults near Los Angeles. That research concluded that stress levels on both of those fault systems are now at or above the highest values recorded anywhere across that entire 1,000-year model period. And it further identified a specific structural junction near Los Angeles called Cajon Pass that could determine whether a future rupture stays confined to a single fault or combines the energy of multiple fault systems into something considerably larger. Geologist Matthew Weingarten of San Diego State University, commenting on that research from outside the study's own team, described it plainly, stating that it is important to see a physics-based estimate confirming the system is sitting at a 1,000-year high, and that the time to prepare is now, not after the next earthquake finally arrives. So now that we've walked through each of these 5 events individually, the obvious question becomes whether they're actually connected in any meaningful physical sense, or whether this is simply a coincidence of timing, 5 unrelated earthquakes on 5 different fault systems that happen to be making headlines in the same general stretch of months. And the honest, scientifically grounded answer is more nuanced than either a dramatic yes or a dismissive no. Let's start with what we know for certain. These 5 earthquakes did not directly cause one another. There is no established physical mechanism by which an earthquake in Colombia could trigger a separate earthquake in Indonesia, or Japan, or Spain, or California, through any kind of direct chain reaction traveling across such enormous distances. Seismic waves from a major earthquake do travel around the entire planet, and they can be detected by sensitive instruments on the opposite side of the globe within hours. But the amount of stress those waves transfer to a distant fault is generally far too small to trigger a major rupture on its own, particularly across the thousands of kilometers separating Bogota from Jakarta or Tokyo from Granada. Responsible seismologists are always careful to draw this distinction clearly, because claiming direct causation across such vast distances without solid supporting evidence is exactly the kind of overreach that damages public trust in legitimate earthquake science. But here is where the more nuanced part of the answer comes in, because while these specific earthquakes did not directly cause one another, they are all expressions of the same underlying global reality, that 2026 has been a genuinely, measurably active year for earthquakes worldwide, and that activity has been distributed across multiple, entirely separate plate boundaries simultaneously. Consider the fuller list of significant earthquakes that have struck around the world this year alone. On June 7th, the Philippines experienced a magnitude 7.8 earthquake. On June 24th, Venezuela was struck by two powerful earthquakes measuring 7, 2, and 7, 5, representing the strongest seismic activity the country had experienced since the year 1812. Mexico recorded a magnitude 7.3 in July. Colombia suffered its magnitude 7, 4 to 7. 5 disaster on August 10th. Indonesia's Flores earthquake struck on August 15th at magnitude 7, 7. Tonga and Vanuatu have also experienced significant seismic activity throughout the year. And this list doesn't even include the countless magnitude 5 and 6 earthquakes that occurred across dozens of other regions throughout the same period, including the ongoing sequence across Northern California's Maacama and Bartlett Springs faults, the moderate but persistent swarm currently unfolding in Granada, Spain, and a magnitude 6. 5 earthquake that struck Mexico's Guerrero state back in January, damaging hundreds of buildings around San Marcos. When researchers track cumulative global seismic energy release, essentially adding up the total destructive energy released by every significant earthquake worldwide across a given year, 2025 emerged as one of the most seismically active years in modern recorded history, with total energy released by earthquakes of magnitude 5 or greater reaching levels close to triple what was recorded in 2021, a year that had already been considered highly active because of a cluster of 3 separate magnitude 8 or greater earthquakes striking in rapid succession. And 2026 has continued that same elevated trend without any meaningful sign of slowing down. This is precisely the nuance that matters here. No single earthquake in Colombia, Indonesia, Japan, Spain, or the United States caused any of the others, but all 5 of them are individual expressions of a genuinely measurably active global seismic year, one where multiple separate plate boundaries around the world happen to be releasing significant accumulated stress within a compressed and overlapping window of time. Whether that global clustering reflects some deeper, still poorly understood mechanical connection across the Earth's crust as a whole, or whether it simply represents the kind of statistical clustering you would expect to see occasionally from a large number of largely independent random processes, remains a genuinely open and actively debated question among seismologists studying this exact issue right now. It's worth pausing here to explain why each of these 5 regions is prone to significant earthquakes in the first place, because understanding the underlying geology helps explain why this kind of activity, distributed across such a wide range of locations, isn't as strange or unprecedented as it might initially feel. Colombia sits above the convergent boundary where the Nazca and Malpelo plates subduct beneath the North Andes plate, a tectonic setting responsible for some of the largest earthquakes in South American history. Indonesia sits at one of the most geologically complex junctions on the entire planet, caught at the collision point of the Indo-Australian, Eurasian, and Pacific plates, a setting that has produced some of history's deadliest earthquakes and tsunamis. Japan sits above the subduction zone, where the Pacific plate descends beneath the Eurasian and Philippine sea plates, a system that has shaped Japanese society's entire approach to building codes, tsunami warning infrastructure, and public disaster preparedness for generations. Spain sits along the slower, more diffuse boundary zone between the African and Eurasian plates, a boundary that produces far less frequent seismic activity than the Pacific Ring of Fire, but remains genuinely active nonetheless. And the United States, specifically California, sits directly along the San Andreas fault system, where the Pacific and North American plates grind past one another in a boundary responsible for some of the most extensively studied and most carefully monitored earthquake risk anywhere in the world. What unites all 5 of these locations, despite their vastly different specific tectonic settings, is that each one sits along an active plate boundary where 2 sections of the Earth's crust are, in one way or another, continuously moving relative to each other, whether through subduction, where one plate is forced beneath another, or through strike-slip motion, where 2 plates grind sideways past each other, or through the kind of slower, more diffuse convergence found in southern Spain. Every single one of these boundaries accumulates stress over time as friction temporarily locks the plates together, preventing them from sliding smoothly, and that stress has to eventually be released somewhere, through an earthquake. whenever it finally exceeds the frictional strength holding the fault locked in place. This is simply the ordinary expected mechanical behavior of an active planet with a crust divided into multiple large tectonic plates, constantly, if usually imperceptibly, shifting against one another. What differs from region to region is simply the rate of that motion, the specific geometry of the plate boundary, and, critically, how densely populated and how well prepared the communities living directly above each fault system happen to be, which is exactly why an earthquake of similar magnitude can produce wildly different outcomes depending on where in the world it actually strikes. So does that mean 2026's earthquake activity is nothing to be concerned about? Simply the ordinary background hum of a normally active planet? Not exactly, and this is where the nuance matters most. While no individual earthquake caused any of the others, and while each of these 5 regions has its own well-documented independent history of significant seismic activity stretching back decades or centuries, the sheer concentration and scale of major earthquakes occurring within this specific stretch of 2026 is genuinely notable by historical standards. A magnitude 7, 4 to 7, 5 disaster killing over 300 people in Colombia. A magnitude 7, 7 disaster in Indonesia, killing dozens and still climbing. A magnitude 7, 5 earthquake in Japan, mitigated by extraordinary preparedness, but still significant in scale. An unusual, historically unprecedented earthquake sequence unfolding in Northern California. And a genuinely surprising seismic swarm in a part of Spain not typically associated with significant earthquake activity at all. Individually, each of these events fits comfortably within the known historical seismic patterns of its specific region. Collectively, occurring within roughly the same several-month window, they represent a level of global seismic activity that scientists tracking cumulative energy release describe as genuinely elevated compared to recent historical norms, continuing a trend that began building in 2025 and has carried forward without significant interruption into this year. This is precisely why the honest scientific answer to the question of what's happening isn't a simple yes or no. It isn't accurate to claim that these 5 earthquakes are all secretly connected through some hidden mechanism that mainstream seismology has somehow overlooked, because the physical evidence for that kind of direct cross-continental triggering simply doesn't exist in the way that framing would suggest. But it's equally inaccurate to wave away this entire sequence as pure coincidence, entirely unremarkable, and identical to any other random collection of years. The data on cumulative global seismic energy release genuinely does show 2025 and 2026 standing out from the broader historical pattern, and the specific concentration of magnitude 7 and greater earthquakes striking multiple, geographically distant regions within a matter of weeks of one another. This August, in particular, is the kind of clustering that legitimately earns close scientific attention and continued study, even without a fully resolved explanation for exactly why it's happening at this particular moment. For the people actually living in these 5 regions right now, the practical takeaway is less about the abstract question of global connection, and more about the concrete, immediate reality of living somewhere with genuine, documented earthquake risk. If you live in Colombia, particularly across the departments affected by this month's disaster, understand that recovery from an earthquake of this scale, with hundreds of confirmed deaths and thousands displaced, will be measured in months and years rather than weeks, and that continued aftershock activity remains a genuine ongoing concern for the affected communities. If you live in Indonesia, particularly across the islands along the Pacific Ring of Fire, understand that this month's Flores disaster is simply the latest chapter in a seismic history stretching back decades, and that the tsunami warning systems and evacuation protocols developed since past disasters like 1992 and 2004 genuinely save lives, provided people continue to take them seriously and respond quickly when warnings are issued. If you live in Japan, take real comfort in the fact that your country's building codes, tsunami infrastructure, and public preparedness culture are widely regarded as among the most sophisticated on Earth, while also recognizing that continued vigilance and adherence to evacuation protocols remain essential precisely because that infrastructure works best when people actually use it as intended. If you live in southern Spain, particularly across Granada, understand that while this ongoing swarm remains modest in magnitude compared to the disasters striking elsewhere this year, it's a genuine reminder that even regions without a strong recent history of significant seismic activity deserve basic earthquake awareness and preparedness. And if you live in California, particularly across the Bay Area or the greater Los Angeles region, understand that this year's research confirming historically elevated stress levels along your local fault systems is not a reason for panic, but it is a genuine physics-based reason to take standard earthquake preparedness recommendations seriously, rather than treating them as an abstract someday concern. Across every one of these 5 countries, the practical preparedness guidance remains fundamentally the same, regardless of the specific tectonic setting or the specific magnitude of risk involved. Know your local fault systems, and whether your home, workplace, or your children's school sits within a mapped high-hazard zone, keep a fully stocked emergency kit capable of sustaining your household for at least 72 hours without outside assistance, including water, non-perishable food, a first aid kit, a battery-powered or hand-crank radio, flashlights, and copies of essential documents kept somewhere easily accessible. Understand your evacuation routes, particularly if you live near a coastline where tsunami risk applies, and have a family communication plan in place for scenarios where normal cell networks become disrupted or overwhelmed, exactly as we've seen repeatedly in the earthquakes striking Colombia and Indonesia this month alone, where damaged infrastructure left entire communities unable to reach loved ones or call for help in the critical hours after the shaking stopped. If you live in or near an older building, particularly one that predates modern seismic building codes, find out whether it has been retrofitted, since these structures consistently prove among the most dangerous in every major earthquake examined this year, from the collapsed apartment blocks in Pereira to the soft-story buildings that remain a persistent concern across California's older urban neighborhoods. And take earthquake insurance seriously if you live in a region with meaningful seismic risk, since the overwhelming majority of homeowners worldwide remain financially unprotected against exactly this kind of disaster. A gap in preparedness that turns a survivable earthquake into a genuinely devastating long-term financial catastrophe for far too many families, long after the physical rebuilding has technically begun. None of this is about generating fear for its own sake, and it's worth being explicit about that distinction as we close. Earthquakes are not a new phenomenon, and the specific regions covered in this video, Colombia, Indonesia, Japan, Spain, and the United States, all carry well-documented decades or centuries-long histories of significant seismic activity that predate this particular news cycle by a very long time. What makes 2026 genuinely worth paying close attention to is not that earthquakes are suddenly happening where they've never happened before, but that the pace, scale, and geographic distribution of significant earthquakes this year has been measurably elevated compared to recent historical norms, continuing a pattern that researchers first identified building through 2025, and that has carried forward without meaningful interruption into the current year. That is not a reason to live in fear. It is a reason to take the same basic, sensible preparedness measures that emergency management agencies across every one of these countries have been recommending for years, and to actually follow through on them now, while the reasoning behind that guidance is fresh and immediate, rather than waiting until after the next headline forces the point home all over again. If breakdowns like this, ones that actually connect the dots between separate global disasters honestly, without either overstating a hidden connection or dismissively waving away a genuinely notable pattern, are useful to you, take a moment to like this video and subscribe, because understanding the real relationship, or lack of one, between events like these is exactly the kind of clarity that helps people make informed decisions rather than reacting purely out of fear or false reassurance. Leave a comment with your thoughts below, especially if you have any personal connection to Colombia, Indonesia, Japan, Spain, or California. Because first-hand experience and perspective genuinely add real value to a conversation covering this much ground. And if you know anyone living in any of these 5 regions or anywhere else along an active plate boundary, share this with them, because understanding exactly what's happening and exactly why is precisely the kind of information that turns anxious uncertainty into grounded, practical preparation. 5 countries, 5 earthquakes, 1 genuinely active global seismic year. The ground has been moving in a lot of places at once these past few months, and while that doesn't mean these events are secretly connected in the way headlines sometimes imply, it does mean the planet's underlying tectonic engine has been unusually busy in 2026, and that is a reality worth taking seriously wherever you happen to live. Stay informed, stay genuinely prepared, and stay with us as we continue following this story in the days ahead.